Hi, my name's Tyler Batillion. I'm the founder of TEBS Lab and the instructor for AI Camp's Practical Python for Machine Learning course. This is a great course designed for beginners who either are looking to learn their first programming language or maybe already speak another programming language but are looking to break into machine learning and get their feet wet. So this course will take you from the absolute basics with Python, including the creation of variables, distinguishing between different data types, all the way through to using popular machine learning libraries like pandas, scikit-learn, and matplotlib to enact data science workflows. It's a 6-class crash course, and it's super duper fun. The courseware is all hands-on, so there will be a interactive direct instruction period where I'll present material, usually in the form of a Jupyter notebook or some Python code, and I'll ask you to work on exercises throughout the class and give you feedback. We also have some challenging exercises at the end of each class period. I'll assign you an exercise. And these exercises at the beginning will range from simple things, again, like creating variables and comparing data with different data types, to, by the very end of the class, we'll have a capstone project where you're going to work on a Kaggle machine learning challenge. So I thought I'd take a second to show you what some of the materials look like. These are all available on GitHub. They're both open source and public domain. So you can take a look at my screen here, and what you're seeing is one of the examples from the first class, where I'll tell you about the creation of variables in Python, distinguishing between different types of data. These are 3 different types of data, even though they're all numbers. We have integers, floating points, and Python even has support for complex numbers. Probably haven't seen those since your high school calculus class or something like that. Square root of -2, right? Okay. Booleans, and also, of course, textual data in strings. So this is what the class looks like at the beginning. I'll walk you through an example that looks something like this. And at the end of each example, we'll have a little micro exercise that everyone will do in class, in small groups, and then we'll discuss the answers to those. So the first class is 3 such samples, followed by an exercise. And the exercises you can find online at the GitHub repository, which is linked below in the course notes. Then by the time we get to the end of class, we'll be working in a more complex environment. This is a Jupyter notebook. And in this Jupyter notebook, we are building a machine learning model, the k-nearest neighbors classifier. We're importing data. This is an open data set, which is bundled with the courseware. It's from UCI. It's public domain data about heart disease. And we're training our k-nearest neighbors classifier to attempt to classify whether a particular person, as represented by the data points in this part CSV file, has a dangerous form of heart disease, or if they don't. And you can see our classifier at the end of this simple training process is 65% accurate. Not so good. But we'll also explore how to, make charts and plot different important aspects of any particular machine learning model that we explore. And we'll also give you background on important ideas like training, testing, and validation data and their uses in the world of machine learning. And also give you a great primer on how to use the scikit-learn library, which supports an incredible number of machine learning algorithms so that you don't have to implement them all from scratch. You can just have a intuitive or, higher level understanding of how the algorithms work without having to write all of the Python code underlying them. So this is what the class looks like a little bit. I think it's a very exciting class. I think it's a really fantastic way to learn a programming language, motivated in particular by real world examples, real, instances of using machine learning. And this format, this way that we contextualize the use of Python through machine learning, I think is extremely powerful. So I hope to see you in class, and thanks for watching this video.